All right, welcome back, Physical Science 20. So we have the third video here dealing with 3.2 stoichiometric amounts. A stoichiometric amount is the predicted amount of reactant relative to another reactant. So let's highlight that. That will react according to the balanced chemical equation. The amounts of reactants consumed are in the same proportions as the coefficients in the balanced chemical equation. Now, a key thing to note here, it's likely worth a star. When stoichiometric amounts of reactants are available, no reactants should remain left over. No reactants should remain. So that's the key point there. Things are completely used up. And of course, in real life, that does not happen. So it's kind of a special, I guess you could say a special occasion here in which we actually have everything getting used up. Later on, we'll see with limiting reagents that one thing gets used up, one thing is likely left over. So you have a limiting amount and an excess amount. But these ones here, we're just simply looking at having that perfect amount, so there are no leftovers. It is important to be aware of stoichiometric amounts when designing any process involving chemical reactions. Sulfur dioxide is a toxic emission resulting from the combustion of fossil fuels. Calcium carbonate can be used to scrub or get rid of it, see, because it combines with sulfur dioxide to produce calcium sulfite and carbon dioxide. Note that sulfur dioxide and calcium carbonate are in a 1-to-1 ratio. As a result, sulfur and calcium carbonate are present in stoichiometric amounts in any mixture containing at least 1 mole to 1 mole. Again, we're talking about moles here, not masses. If less than the stoichiometric amount of calcium carbonate is used, we'll have some leftovers here which go into the atmosphere and can cause acid rain. In practice, an excess carbonate is usually used. So in the real world, we'd likely use more than enough of this. Even if we have leftovers of calcium carbonate, it's okay as long as we use up all of that. So as we'll see later, non-stoichiometric amounts are combined. One reactant remains when the reaction is complete. So I'd like to go through one of these questions in the assignment here dealing with determining is it a stoichiometric amount. So aluminum undergoes a synthesis reaction with oxygen to form aluminum oxide. Determine which of the following, A, B, or C, are stoichiometric amounts. So if we take a look here, let's say if we were given 2 moles of aluminum and 1.5 mole of oxygen, are those going to be used up? And realizing it's a 4-to-3 ratio. Now, it's kind of difficult to see because it's kind of a difficult ratio to deal with, but we can still work it. So the key thing here is pick either one of these. Pick either one. I chose to pick aluminum. Okay, so if I'm going to try to use up all the aluminum, how much oxygen would I need? So I have 2 moles of aluminum, and according to this, 4 moles requires 3 moles. So 4 moles requires 3 moles. So 2 times 3 divided by 4, I get 1.5 moles. And oh, look at that. As luck would have it, that's exactly what I have here. So I would say yes, therefore it's stoic. It's a stoichiometric relationship because I end up using both of these. Now, in B and C, when you do it, chances are you're not going to end up using those up. So it would be a non-stoichiometric amount. And you may have one left over or not enough of one to completely react. Okay, so that's how you do that process there to determine which are stoichiometric amounts. And then the rest of the assignment is the 3-step calculation like we did. Given a certain amount of grams, figure out the amount of grams in something else. All right, so that's it for FC 3.2, and we'll see you again.